Okay, back with the next video. So I bought this, supposed to be 316. Well, as you can see, that magnet, that does stick to the magnet. So not 316, so it may fail again. That was the negative plate. I sort of stuffed that up. Now I don't feel so bad because I made it too wet. I put 8 extra drops instead of 5 because it felt a bit dry, but when I compressed it, it squirted out everywhere. So the positive one is up all right. So slightly different today. I used 2 grams of this aquarium activated carbon and 2 grams of the zinc chloride feather carbon. This was feather carbon carbonized, then soaked in zinc chloride and then microwaved. So both of these have the same amount, 2 grams of feather carbons and 2 grams of activated carbon. The negative one has 1 gram of zinc, 3 grams of cement, 5 grams of water plus 8 drops, but probably keep it to 5. Also 3 grams of graphite in there. The positive one, same sort of deal, except for it has nickel hydroxide, 1 gram, feather carbon, 2 grams, activated carbon, 2 grams, 3 grams of graphite, and 3 grams of cement, and 5 grams of water, and 5 drops. It was 3 drops, so it needed extra 2 drops due to probably the feather carbon having more surface area. It was drier, and we're in winter here now, so it should be not so bad. But so anyway, getting onto it. Resistance on this positive one, just over that area. We're looking good. I put an extra bit of weight on it, so it was a bit heavier. So 5.1 ohms. Ohms 5.1. And for the negative one, hang on, I'll just connect the leads. Okay, so for the negative one, I've got to be careful. This one might be a bit dodgy. Not so good because the compression wasn't, it squished out. So we're up high here, we're about, oh, don't break it. Alright, I'm only lightly pressing. Oh, okay, works better up there. And it does down there. It's a bit high there. It's all over the place. I had them both under the same thing, so this one took all the compression and that one just squished out and then just didn't compress. I drilled like 12 holes, about 6 mil, 3 across, 3 down, 3, 3 and 3 in here. So the carbon can go through and bond, because this is pretty flimsy. If I could get some, oh, see, breaking that bit off from the top lip there. I gotta be careful. So if I can get some 316 of this quality thickness, would probably be alright. Yeah, I got this one. Where is it? In here. That's a bit thicker though, and that is definitely 316. So I'll set it up ready for a charge, and we'll see what happens. Cells in the electrolyte. Setting up for a charge. Try for a couple of hours. It's at 2.5 volts, so let's connect the charger. Okay, we're 600 milliamps at 2.5 going in. I'll keep the plating out of the electrolyte like that on both cells. If you can sort of see that one. I was thinking maybe the amperage on this one burnt it because it's a thin wire, because this wasn't really in the electrolyte. but it creeps up, so it could have melted and corroded. We'll see what happens with this one. Right, I'll be back when that's charged in a couple of hours or so. First charge on the cell, 3 hours and 5 minutes. Starting 20 milliamp load now. Seems like it might be working, but we'll see how long it goes for. I'll get back when it's finished. The zinc chloride activated feather carbon seems to be doing something, because the other cells were never 1 volt at 1.5 hours, or 126. So that's looking interesting. And considering I made the negative plate a bit dodgy, it's looking alright for now. Don't know how the stainless stuff is going to hold up. Probably won't. But that's the major difference, is the feather carbon's 2 grams each side. First discharge is complete, 2 hours and 21 minutes, which ain't too bad. And what do we got? We got 47 milliamp hours and 53 milliwatt hours. Average voltage 1.13. So we'll get back in 5 charges and see how we go. Well, if this cell keeps this up, it's a winner. 5-hour runtime on a 3-hour charge today. Second charge, 101 milliamp hours, 86 milliwatt hours. So it had a different curve this time. The other one sort of ran and then dropped right off after an hour and 20. So what did we get? We got only right here, yeah, probably an hour and 20 something for 1 volt. But it tapered off more this time. Interesting. I thought it would have just failed, but maybe it's something to do with the see, it's a solid piece of steel plate, or 304 or something, and comparing it to the wire, we can't get many electrons over that wire because look how tiny it is. I think that might be the difference. The collectors. Okay, that was the 6th run. It's down by heaps, but this piece fell off. That was at the back of the plate up against the plastic, so that's some sort of carbon and cement with some zinc. And here on the plate, what was running the cell was spongy zinc that plated onto the stainless. How odd. It still ran for 3 hours and 8 minutes with that, like that. Oh, there's something floating in the liquid, I think. Ah, it's a rubber band from one of the other experiments. So the positive ones sort of got a little weirdness happening there. The back side of it's alright. Very odd. So I guess I'll try again. I'll make a I have 316. These are a bit thicker, but I'll drill some holes and cut some slots where the carbon can be pressed through it. So I'll set that one up probably make a positive one again too and see how that goes. Alright, hope you enjoy this short... Oh, hang on then, we're going to end this battery run. So the results, we got to 6 charges before the negative one fell out. So what do we got? We started off average 47 milliwatt hours, and then the next run we went up to 101, then we slowly started declining down to 63 and 47 with the bung cell. Actually, I might charge it up one more time tomorrow with that, just that steel plate like that, and see what happens, and then get back. Alright, I'll do that because I don't know, I didn't pull it out of the liquid, but I did notice part of it on the sides was gone where I could no longer see it. So it might have been like this for a couple of days. The cell's just had a 4-hour charge. I just started the 20 milliamp load test. It's just that strip of non-316 stainless steel now, with some zinc attached to it by electroplating, I guess. Because the other part of the carbon, that all fell off. That was on the back side of the cell. All the front side just disintegrated. That must be some zinc built up there. Those shiny bits. So it's already dropped. Normally it takes 16 minutes before it's down to 1.3. So the carbon actually on the metal was actually increasing its surface area while it was lasting. And the milliamp draw isn't as high now when it's charging. We'll see how long that runs, and then the next test will be a zinc plate just to see how well the positive side's going as compares it to the rest of the other cells, and we'll see what happens. And then in the meantime I'll make another negative and a positive out of the 316. I have this stuff which is thicker. That's been in electrolyte before and it's not really damaged. So we'll see how that goes with some real 316. I'm surprised it's still running. So at 2 hours now, 41 milliamp hours, 32 milliwatt hours. That's just a piece of stainless steel and the carbon pad for the positive. Well, that makes a cheaper cell, doesn't it? Not a bad run for the cell for just having a stainless piece of metal on the zinc side. The negative. 248. I'll test it again tomorrow, see what it gets. It did drop from yesterday's run though. It may just stabilise now at this.